Episode 179 of CppCast with guest JF Bastien, recorded December 5th, 2018. Today's sponsor of CppCast is PVS Studio. PVS Studio is a tool for bug detection in the source code of programs written in C, C++, and C#. PVS Studio team will also release a version that supports analysis of programs written in Java. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at jetbrains.com. In this episode, we discuss designated initializers and StandinBed alternatives. Then we talk to JF Bastien from Apple. JF talks to us about the San Diego C++ meeting where he was the EWGI Chair. Welcome to episode 179 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going?
Pretty good, Rob. How are you doing?
Doing okay. Doing great since last I saw you 2 hours ago.
Yes, it's a bit of an inside joke for our listeners, I guess. But we're recording 2 episodes back-to-back for the first time ever.
Yes, we've sometimes done 2 in a week, but we're doing 2 in a day just for scheduling reasons.
Yes.
Yeah.
So this is the disembodied voice of the past or something like that.
Right. Well, anyway, at the top of every episode, I'd like to read a piece of feedback. We got a iTunes comment here, and it says, great host and always informative. For this from Plain Jim. And he says, this is a wonderful podcast that helps me learn about important people in the C++ and software community. It's not dry at all, and I really enjoy the kind and professional hosts who make it very special. So thank you, Jim. Sweet. Yeah, very nice.
It's not dry at all.
Yeah, well, I could see how some programming podcasts could be quite dry.
Yeah.
Yeah.
No, I mean, I would expect ours sometimes is, honestly. But
yeah,
it's good he doesn't think it is.
Yeah. Well, thank you for the kind words, Jim. We'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us reviews on iTunes. Joining us today is JF Bastien. JF is the C++ lead for Apple's Clang front end, where he focuses on new language features, security, and optimizations. He's an active participant in the C++ Standards Committee, where he chairs the Language Evolution Working Group Incubator, EWGI for short. He previously worked on WebKit's JavaScript core just-in-time compiler, on Chrome's portable native client, on a CPU's dynamic binary translator, and on flight simulators. JF, welcome back to the show.
Hey, thanks for having me again.
You know, this is your second time, right? But I can't recall if we asked. It's been a long time, like 3 years or something, right?
Yeah.
Something like that. Maybe, yeah. I think last time we talked about WebAssembly shortly after it was announced by the 4 browser vendors.
Yeah.
Yes.
Yeah.
And now that's a real thing. That's in the real world doing things.
Yeah, it is. It is. It seems to be getting a lot of traction among just web developers in general. There's still a lot of ongoing work, but the basics are there and seem to be working pretty well.
Yeah.
I just saw a comment on Reddit from someone that said that they are in the process of porting some C++ code to TypeScript and was looking for some guidance. And I have respect for TypeScript, but my immediate response was, why don't you just compile that C++ for your web browser?
Mm-hmm.
Yeah, that's
thing you can do now.
Certainly easy. It's certainly the easiest approach, but in a lot of cases, if you do something that's native to the platform that's well supported, you can trim down code a lot and have kind of faster execution. Not that WebAssembly can't get that, but there's a cost to the bridging, so you kind of have to think about the way you're going to do that bridging.
Right. So if you're having to do lots of bridging, okay.
Right, exactly. And so there's a lot of upsides if you're trying to do compute intensive stuff, WebAssembly is really good. But if you're going to try to get, say, data in and out of the WebAssembly sandbox or something like that, then your C++ code might not be the bottleneck, right?
Right.
So in some cases it makes sense. In some cases, just TypeScript or JavaScript are really good solutions. Like that's what the web is, right? They do it really well. So
right.
It's really a question of what's the better tool for the job.
Yeah, I would be, it's just a random comment on Reddit, but it would be curious to have a full conversation with this person and see what they had attempted so far and checked out and everything. Yeah.
Yeah. Okay. Well, JF, we got a couple news articles to discuss, and then we want to talk more about, your own thoughts out of the San Diego C++ meeting and the work you did as the EWGI chair. Okay.
Sounds great.
Okay. So this first post is, on Therocode's blog, and it's exploring C++20 designated initializers. And it is a really good post going into kind of the history of aggregate initialization and why designated initializers are going to be a great feature for C++20.
Does kind of seem like it was a long time coming. I don't know when it made it into C, but a while ago, right? C11 or before?
All right, this is a feature that came from C, right?
Yeah.
Right, it is. The difficulty, though, is C++ has constructors, and so designated initializers, just based on that, have a few issues. If you can reorder the order of elements or something like that, it's the same as in a constructor where you use the colon and you have the list of initializations. If you don't put it in the same order as it was declared in the struct, then there are not necessarily obvious rules on what gets initialized when. And so I think that was one of the biggest holdbacks from getting it into C++, just kind of getting some sane rules in there.
Right.
And otherwise, the C rules are kind of weird in some cases. And so the committee really wanted to not just adopt the C feature as is, but have something that's compatible yet fits well within C++, I think.
And it's ultimately not going to be fully compatible, right? Because it will allow braced initialization of the named designated initializers, which C will never allow. Is that correct?
Well, I don't know if they'll never allow it, but
well, no, I mean, right, but it would be incompatible today.
Yeah. Certainly, there's a common subset that'll work in both, and then there's things both in C and C++ that won't interoperate at all.
Okay, right.
But I think we got a pretty good design out of that feature, so I'm pretty excited.
No, I'm pretty happy with it. The only thing in my playing with it, because as far as I know, no compiler currently supports the braced initialization syntax. They all basically just, as far as I can tell, for the most part, enabled what they had from the C side of things at the moment.
Right.
And some of the things that I want to know is, like, how does this interact with deduction guides, that kind of thing. Like, because you can kind of, if you squint your eyes, kind of synthesize a constructor by using a deduction guide. And I want this to play nicely with deduction guides, but it wasn't clear to me in reading it and playing with it how well it would.
Oh, yeah. Yeah, I don't know.
Okay.
I have no idea.
Okay. So next post we have is StandinBed for the poor, C++ 17 users, or cross-platform resource storage inside the executable. And this references StandinBed, which we talked about with Jean Menide a while back. Doesn't look like StandinBed is going to make it into C++ 20. So this is kind of an alternative tool that you can use for similar functionality. And the post kind of dives into how he goes about doing it.
Yeah, it makes a lot of sense.
Yeah. I didn't want to interrupt you,
work around that, yeah, totally.
And it
Go ahead. Go ahead, Jason.
The Reddit, specifically the Reddit post about this article, Jean Menide, he comments, like, has a discussion with the author of this article about the pros and cons of the different options for how he implemented this. So I would suggest that for our listeners who want some more information on the background and history of these options.
Right, and I expect that we'll see. So we saw. I don't want to give too much away, but we saw StandinBed in San Diego, and I expect we'll see an update in the next upcoming meeting in Kona. And I think there's a pretty big discussion going on inside the committee about stuff related to that in general. So I'm pretty hopeful that we'll get something in that direction. I'm just very worried about the build system implications, right? If you can pass a const_expr string to StandinBed, that like at compile time you figure out which file to include, then your build system has to run all of const_expr before being able to determine the dependencies. Now, it's kind of a niche feature in my opinion. So I'd be really happy to not have that part of the feature, yet have the other type of dependencies, right? Especially with modules, like you kind of want to have really quick, easy parsing of the module, and StandinBed kind of defeats that, whereas modules tries to give you, kind of make your build system easier to support in some senses. So I think there's a balance to be struck, and it's not clear where the committee wants to land on that.
So you're saying, if I understand correctly, a string literal is fine, but if it's any constant expression, that becomes more difficult.
Well, so the idea is, you would say StandinBed foo, where foo has been derived from playing an Amiga emulator as a const_expr thing or whatever.
As a hypothetical possibility.
Right, as a hypothetical thing. Then I'd be worried about the compile time aspect of that, of figuring out what the dependency was, right? Like I'd like to construct a graph really quickly by quickly preprocessing the top of every file, right? And then when you see like the keyword module or something like that, you're done with preprocessing the module. It's in a perfect, if modules are in C++20 world, like your build system should be able to figure out file dependencies really quickly, in an ideal world. And I'm worried that StandinBed would defeat that. But at the same time, like, I want StandinBed, right? Like,
oh, yes.
I've done stuff similar to this blog post before, and so it's a really interesting feature to have, to be able to say, take this file and const_expr create this result from the file. So yeah, I kind of want both.
Yeah, the project I'm currently working with a client on has been dealing with some version of the solution, I think for 6 years or so, with rolling their own CMake kinds of things for trying to make effectively a single binary that has everything it needs in it. That's really our goal. We don't need the data at compile time, but we definitely need that data in the binary and access to it at runtime.
Right.
And that aspect of this, I think, is, highly necessary. The compile time part is fun because I like doing compile time things.
Right.
Okay. And then the next post we have is range of a better span. And this is a follow-up post where the author just talked about why he doesn't like span. I didn't read the first post. Did you, Jason?
I did not.
Okay. But this one just goes over kind of refreshing why he doesn't like span and this alternative solution with using the ranges, which are going to be in C++20.
Yes.
Yeah.
Yeah, the committee is pretty split on that in general, on how span should look, whether its size is signed or unsigned, and other stuff around that, how comparisons work or don't, whether the type should be regular or not. So there's kind of a lot of different trade-offs in that design space, and people who are much better than me at the library side of things are having pretty serious discussions about this, and Cohantime's part of that. So it's been good to see people try to find an agreeable solution.
I'll be curious how it all shakes out. I don't feel like I personally have, I don't know, a horse in this race or whatever. Like, whatever the committee gives me, I'll be fine with, basically. I have to admit, though, when I was reading this article, I got distracted by something right towards the middle where he says, but in general, I think we should try to move away from the header source file separation model. And that's a link to a separate article that he had written a month and a half ago. And it seems to be effectively an argument for header files, like just
all
putting everything online all the time. And I know organizations who are doing this, right? We discussed that with Lenny 2 episodes ago. Yeah. And I was just kind of curious if JF had seen this or if he had an immediate gut reaction to it.
Yeah, well, I mean, especially in the pre-C++ 11 times, like we used to do that for header-only stuff everywhere, kind of like what Boost does, right? And I've kind of gone back and forth on things like that. And in a way, I find it hard to navigate when there's all this code in there, right? I kind of like it's not just like you abstract away the class, but it's also as a human, you read the code. I like having the abstraction of like the header and the CPP file or something like that. But at the same time, you could argue that's the job of the IDE to kind of hide things from you unless you actually want to see them. And again, I kind of go back and forth between using an IDE and not. So I use Xcode fairly extensively, except when I use Emacs. And there's no logic to my usage. I just kind of go back and forth and try to deal with the two of them really well. I think modern code bases care about compile time a lot, and so they don't tend to put everything in the header file that much. But I guess we'll see what happens with modules, right? How that changes the landscape, how IDEs make your life easier there, or not, right?
So, JF, do you want to start off by just telling us a little bit about the new position you had in San Diego as the EWGI Chair?
Right, yeah. So Herb sent out an email, or a blog post, I guess. Well, first he sent an email to the committee, then he posted his blog post saying, like, we've got a huge influx of papers coming in. And it's kind of interesting because Bjarne had kind of predicted it in a way, and everyone was like, nah, you're just worried that there seems to be a trend, but that'll die down. And it turns out Bjarne was really right. So for San Diego, there was an influx of papers. I think it was 276 or something like that, where that's more than twice that there's ever been in a pre-meeting mailing. And so that's not possible to read all the papers. I think he calculated it's more than 3 times the works of Shakespeare or something like that. Like it doesn't make sense, right? And at the same time, there's an influx of new participants. So I think there were 180 people who showed up in San Diego. Now, some of it is, historically, there's been an influx just before a standard kind of gets nailed down, right? So before it's kind of finalized. And so some of it is trying to get last-minute features in or last-minute fixes in so that the standard is better. And you definitely want to prioritize those things. At the same time, there's features that you don't want to rush into the standard, right? So you want to say, well, let's take a step back, and this feature could make it to 20, but it's not a good idea. We're not confident about the quality of the feature yet, even though it might seem good. So there's kind of balance to be struck. And also because we have a lot of new people coming in, it's hard to know how to write a paper that does the right thing. There's a lot of unwritten rules about how the committee works that people have to kind of just figure out. And we've been trying to get better at documenting those things, but it's just a fact that the committee's not that great at documenting those things yet. So you'll write a paper and you'll think, like, I got this, it's really great. And then you'll realize, oh, there's all these things I didn't follow. And that's true both on the language side and on the library side. And so I think the goal that Herb had was to really help new people write higher quality papers, by having an incubator that tries to work on the features so in a smaller group, such that when it gets to the library group or the language group, the feature is way more polished. You don't waste as many people's time trying to polish something, right? So that's one aspect. Another aspect was to just say no to features that shouldn't go forward as early as we can with as few people involved as necessary, right? And it's not really saying no, but it's more figuring out why something fits or doesn't fit and what could be done to make it fit, right? Sometimes you're saying no because you'd like to see the feature done a different way. In a lot of cases, it's just, well, this is nice. We could create a macro for this, but really we should work on context expert to make it happen instead, or on reflection to make it happen instead. So that's another thing of trying to redirect the feature of like, well, you want to do this, but have you thought about doing it this other way? And then it's trying to merge features as well. We had, 2 proposals for pattern matching, which is a huge language change. And we don't need 2 proposals for pattern matching, right? It's good to get to a certain point where you can evolve proposals separately, but at a point in time, you got to choose one. So the goal in the incubator is to kind of try to see trade-offs and try to get just one feature out of 2 papers. So I think those are the goals of the committee. And at the same time, the language group and the library group want to move forward on certain papers that will go into 20, but you don't want to pause the world and not see anything that will go after 20, right? You want to have some amount of iteration, even though you're trying to finish 20, you still want to work on future features, just like, pattern matching. So that's another goal of the incubators, is really, let's get a bit of iteration going so that, once 20 is finished, we have stuff that's just not all brand new, that's kind of ready to go, or closer to ready to go than if we just hit the pause button. So that was really the goal of the incubators, and I think it was a pretty good setup that Herb had to try to make that happen. And then he asked me and Bryce to chair the language for me, and Bryce the library incubators. And it seems like it's worked pretty great. Throughout the week, we had 10 to 20-ish. I think at the top we had 30 people in the room for pattern matching at some point, but not that many people compared to the other rooms. So I think that goal was met. We saw, I think for my group, something like 30 papers. So that was pretty productive, I think.
In a way, it sounds like the incubator would be the more interesting tour a new person to visit, because you are just, you're seeing the exciting new things coming in and kind of seeing the start of the process, I guess.
Yeah, definitely. Although part of the goal of the incubator is to also bring some of the worries that the later groups would have to those papers. And so I think it's useful to, if you're new to the committee, kind of shop around the different groups, see what they talk about, see what concerns they bring up, and also see who we really have, I don't think there's one expert who understands all of C++, but in the committee there's key people who understand things very, very well, and knowing who to go to get, good input on a particular topic is also really useful. And so it's useful to go around and see who everyone turns to for particular things, so that, you can not waste everyone's time and just kind of talk to that person directly if you have questions on a particular thing. So, and different groups really have different worries, right? The final groups, the core group and the library group really care about getting the wording right, integrating things into the standard really well, whereas the evolution groups have more kind of higher level, where should the language go or the library go, what should it do, how should that feature look like, and things like that. So there's really different concerns, and to me, it was obscure before joining the committee how that part worked, and just seeing it happen has been kind of really interesting. It's a fairly well set up set of responsibilities, and people kind of hold themselves to that. It's really well done, I think.
So if you're in one of these discussions, like an incubator, and you're like, well, we don't really know how this would interact with this other feature, and so is the expert on that, but that person's in a different room, do you ever go try to grab that other person real quick and
Oh yeah, definitely.
ask?
And
Okay.
There's an IRC channel where the committee kind of we announce which paper is being discussed where, and where people get queries for hey, could this person be sent here, or you're about to present, how about you show up, type of thing. Because the scheduling is pretty flexible, right? There's so many people, you can't have everyone in the room at the same time, and so you kind of give a heads up to people. And definitely when there's a question where you'd like to have someone in the room, that happens. Although what we usually try to do is we ask, we post a schedule internally of which paper is going to be discussed roughly when, and then people can either talk to the chair or post on the wiki or something hey, I want to be there for this discussion. So you try to ping them beforehand so that they're there. So they kind of self-nominate. But another thing we do, at least in the incubators, for example, we did this with StandinBed, is we say, well, we're not ready to forward this, but this isn't the group to make this decision. We'd like you to go to, for example, the language evolution group, ask this set of questions, then come back here with the answers, and we can iterate in that direction. So we did that with StandinBed. We did that with no discard. So there's a paper that adds a message to no discard. And we want to know, would library use it? And if so, how? Do they want to have a policy of this, or do they not want to use it for a variety of reasons, right? I think it's important for us when we standardize a language feature to know whether a library would use it and how. And so that's part of the discussion. So we forwarded that paper with that question still open.
Yeah, it's interesting to me that you just brought up no discard, because I just got a message from someone on Twitter saying that he started putting no discard throughout his code base, and then wrote a libtooling tool to go in and automatically apply it to every function that he thought was appropriate, and ended up finding apparently dozens of bugs in their source because they were ignoring things they shouldn't have been dropping. And it seems like a lot of people are like, wow, no discard should kind of almost be everywhere. I mean, for some definition of everywhere.
Right, and it's pretty interesting. The committee's been discussing this week, and there's places you don't want it, right? You might say, well, it's a kind of misfeature of the library if it returns something that's fine to ignore, right? But something like printf is the one nobody ever checks, right? Like nobody looks at the return of printf. But you might argue, well, you shouldn't have been returning something if nobody checks it. But I guess the idea is also, should the default in the language be no discard, and then you would say maybe ignored in the cases where it makes sense to ignore them. So I think what the committee is going to try to do is write a paper that tries to see where you should apply it or you shouldn't as a kind of policy matter, and then decide whether we actually do apply it to the STL or whether it's just a proposal that implementers do this. So I think Stefan STL at Microsoft volunteered to write such a paper, and I guess we'll see where it falls. But the thing to remember is attributes are kind of weird in C++, where compilers can just ignore them, and so they're not really normative in that sense. And so even if we put it in the whole STL, it doesn't really mean anything. Although I'd like my STL implementation to follow whatever rules are there for attributes. So attributes are a bit weird, honestly.
Yeah. But it's almost peer pressure in a way. Like if 2 out of the 3 compilers are giving us good warnings on no discard, the third one kind of has to catch up and do it too. Right.
Yeah. And in a way, the language, the warnings in language implementations already give you warnings on no discard, right? So if you do some comparisons or certain expressions and they have a side effect, but you don't look at the result, then either with WAll or something, you'll get warnings in some cases. And so it's a bit weird that we have a distinction between library and language, where discarding things already warns in some cases, but not others. Right. So I guess it'll be nice to kind of find those bugs through no discard.
Mm-hmm.
So we mentioned StandinBed and no discard. Were there any highlights out of the EWGI group? Were there any papers that you kind of just forwarded straight on to Evolution?
Yeah. So total we had 60 papers on our plate. We saw 30 of them. There's 5 that we sent as is to EWGI, and 2 that we sent just to get feedback. And there's 6 that had no consensus to continue work as is, but we gave feedback to the author on why we think that's the case and what could be done to change this. So at a high level, the ones we sent to EWG were really just ready, and I think it was trying to make sure that they were ready before EWG saw them, because their schedule was really, really overbooked. So first one, there was array size deduction in new expressions, which was kind of just an oversight that was missing in the language. I think Bjarne pointed it out. Nobody really seems to have run in this ever, but it was just a weird inconsistency. And so this was just fixing something that Bjarne was just like, oops, I made a mistake 30 years ago. How about I fix it? So that was kind of neat. Then there was something that was almost a no-op where we're making string literals for char 16t and char 32t be explicitly UTF-16 and 32. It was effectively the case, but we didn't say it, and the wording around it was a bit weird.
Okay.
And so the paper just fixed things in a way that was sensible. Then there was something about named character escapes, which came out of the SG16 Unicode group that I really liked. So the idea is, when you do Unicode literals, you can do \u something or some syntax like that in a character literal, and that inserts a Unicode character in your string.
Right.
And you have to provide the code point for that, and that I don't know about you, but I don't know that many code points off the top of my head.
Right, yeah.
So I know that 20 is a space or whatever, but that's about the extent of my knowledge. What that does is there's a Unicode standard for named characters for Unicode, and those are stable names, and so it means you can put the Unicode character in your code using that escape sequence, and you name it, and you say like, this is the character I have, and then it's obvious what the character is, right? Because it's spelled out. And it's useful because, just \u escapes are really non-obvious what you're talking about. But it's also, if you just insert the Unicode character in your source codes, some of them look like other characters, and you kind of don't want that in a lot of cases. So having the named escape makes it much nicer, where you can just say, no, this is not like, the letter K, it's the letter K for Kelvin, right? Which is separate in Unicode for some weird reason. So it allows you to kind of call these things out much more easily in your source code. So that's really neat.
So is this like an optional name that's with the code point, or you name it outside of the string literal and then can use it inside of it?
So it's instead of using the code point, you can use that. So it's really like, you say like, put this character here inside the string literal. And so then it substitutes that in there. So it's the same thing as \u something, but with the character, the name instead.
Okay.
So that was a pretty neat feature. It's, adopting something that Unicode has standardized, but Unicode gives you a lot of options on what you accept. It allows you to ignore like underscores and dashes and spaces and ignore the capitalization and other things. And so we had to choose which subset of that we were going to allow. And I think we allowed something that is, non-surprising, but that works pretty well.
Non-surprising.
Well, yeah, so because you can change the capitalization and add spaces and dashes and whatever according to the Unicode spec, and then that's the same stable name in effect, and that seems a bit weird. So I think we allowed capitalization to change, but not spacing and dashes and underscores.
Right.
So it sounds like the incubator groups were definitely a success. Do you think they're going to be meeting at like all future ISO meetings? Is that not decided yet?
So the intent was to relieve pressure for San Diego, but I think at least for the near future, we'll still probably meet, and we'll try to gauge how much influx there is for new papers, right, and how much of a need there is. So in the case of EWGI, we only met for 3 days out of the 6 that the committee usually meets, and EWGI met for 3.5, if I remember correctly. And so we'll kind of go on a as-needed basis, and we might do telecons in the middle to try to move certain things forward as well. But if there's no need anymore, then I don't think we should keep meeting. Right, the same way the other study groups have shut down over time. Right, so the file system study group doesn't meet anymore because the file system is already shipped. So I guess we'll see how things work out.
Okay. I wanted to interrupt the discussion for just a moment to bring you a word from our sponsors. PVS Studio Analyzer detects a wide range of bugs. This is possible thanks to the combination of various techniques such as data flow analysis, symbolic execution, method annotations, and pattern-based matching analysis. PVS Studio team invites listeners to get acquainted with the article Technologies Used in the PVS Studio Code Analyzer for Finding Bugs and Potential Vulnerabilities, a link to which will be given in the podcast description. The article describes the analyzer's internal design principles and reveals the magic that allows detecting some types of bugs. So I want to maybe talk a little bit more about some of the other core features that had movement at San Diego. There was a special meeting on modules before CppCon, and they're now saying it achieved consensus. So it looks like it will be making it into C++20.
Well, so it's still not clear. So module hasn't been voted into 20 yet, and we'll see what happens. I think the upcoming meeting is the last one to make that happen. But fundamentally, there was the TS, which was championed by Gabby at Microsoft, and the TS did a lot of things really well, and at least within Microsoft's experience, they had a lot of very positive uptake of their modules approach. But at the same time, the implementation of modules that predates the TS that exists in Clang has had a lot of success with Clang users in general. Especially, Google was really behind the way Clang did some of the features of modules. and so was Apple. And so we worked with Google to try to take the core of what we thought Clang did better than the TS, and then Richard Smith wrote a proposal called Atom, I think, that had kind of alternatives for what the TS was trying to do. And he was joined by Nathan at Facebook, who works on the GCC implementation of modules. And so I think by having those three implementations try different things out and see what works for their user bases, we got a better outcome through that meeting that we had about modules. And that's where we reached consensus, and where there's ongoing work to try to get the TS into a state where what we voted on is what the wording reflects, and then that can be merged into the IS potentially at the upcoming meeting. And so I think everyone's kind of happy with the outcome. I think we got some really good changes in there.
Cool.
Okay. How about the coroutines proposal? There was the core coroutines paper that was discussed, and that's another one where it looks like there's going to be a decision to be made in Kona.
Right. So coroutines as a TS got a lot of traction early on, especially because Gore, who's also at Microsoft, did not just the implementation in MSVC, but he went and did an implementation in Clang and optimized it through LLVM as well. And he gave some pretty entertaining CppCon talks about it. And that really helped the TS move forward much faster because he was willing to do all that work to show that it's not just a one implementation thing. Now, the problem was as people start using coroutines, they realize that they had issues with some of the capture, right? So it's not obvious when or when a coroutine is going to capture certain things and cause heap allocations. And it looks a bit different from what Lambda syntax looks like. And so there was a feeling by some people that coroutines should kind of look more like what Lambdas look like. Without being very clear on what that meant, right? So the core coroutines paper tried to explore some of that, and at the same time, there's maybe a dozen or so customization points in the current coroutines TS, and it's a bit weird. Like the language feature of coroutines reaches into library-like things to do customization. Looks a bit weird, and there was a feeling that we might be able to do something better, but not really clear on what that would be. And so that's the other thing that people were interested in exploring. So that's what core coroutines tried to do. The first version of the paper was really rough. It was very hand-wavy and didn't really have enough concrete stuff to convince people. And so coroutines was trying to move forward, but barely didn't make it to the standard. And now core coroutines is in a better state. The authors have been working really closely with Gore to address some of the issues they have. And at the same time, some of the Facebook people brought up worries that they had with just kind of the asynchronous natures of coroutines and how would you would use them and integrate that with the library and other stuff. So that's another thing that's ongoing of trying to get all of these actors really happy about what coroutines do, so that if we do vote into 20, so that it's a really solid feature that we don't regret. And there's a lot of demand for coroutines. People really want it. So it's it's a bit difficult to say, well, let's hold out for 20, right? Like maybe we want to see what it'll look like with parallel algorithms. Maybe we want to see what it'll look like with networking, or maybe we don't. Maybe we believe it's good enough to ship as is. So I guess we'll see in Kona how things fall.
And I have to ask you about the paper you presented, signed integers R2's complement.
Right. Yeah.
How did that go?
Yeah, so I presented that paper a while ago, and I gave a CppCon talk about it this year as well, and it went really well. Surprisingly, I thought I would get more pushback. So initially, I came at it at a kind of a mild rage because it causes, like, that type of thing causes security bugs, as I talk about in my CppCon talk, and I didn't know of any architecture that was to complement that was relevant to C++ nowadays. And so I kind of started doing some research to figure out, well, why do we have, well, first, what liberties do we have in C and C++ implementations with respect to signed integer representation? And second of all, does anyone take those liberties? What does it look like when people try to use them? And then if we made changes, say we said everything was just complement, what changes could we make? And what effects would that have on the language and on users? So initially I was proposing that not just storage be two's complement, but also arithmetic. meaning that Overflow would wrap. And that received huge pushback, partly because in a lot of cases, when you have a bug, having wraparound wouldn't actually fix your bug. And I go into examples of that in my CppCon talk, where just there's bugs where wraparound was the behavior that occurred, and the bug was still there. Like in Donkey Kong and Pac-Man, you have bugs like that, and having wraparound wouldn't fix anything. Same thing with like the Ariane 5 rocket that exploded a few years ago. Having wraparound would not have prevented the rocket from exploding. So one of the worries people had was, well, you're going to find wraparound, it's not going to fix any bugs, but it'll make life harder on sanitizers, because then they can't just trap when wraparound occurs and still be a conformant implementation of C++. So that's one worry that people had. And at the same time, there was a worry that it would hurt performance. And there's numbers that people have measured in the range of, insignificant to, 30% perf hit if you were to define integer overflow to wrap. And I think we can make up some of that perf hit, but you can't just say, well, we made the language nicer, but your code now runs 10% slower, right? So it's something that people weren't willing to commit to making integer overflow well defined. And so what we did instead is we defined the storage, but not the arithmetic. And the goal is instead to have library features that allow you to express the type of behavior you want on overflow. Whether you just want to, track whether overflow occurred and do something later, whether you want it to trap, or whether you want it to wrap or something like that. So I think as a library feature, we're going to try to do that. And the numerics group has been working on that for a while. So I presented the paper, went really well. Aaron Ballman presented it to the C committee. They want the same thing to be adopted for C. And then Jens Maurer took my wording, which was kind of expressed in terms of engineering wording, and transformed it into a more mathy thing. So he wrote a paper that was eventually adopted that made everything more mathy and in my mind, less intelligible. But that's the way the standard is usually created, and so it should be equivalent in all cases. But the core group thought it was really important to have a more mathy description rather than engineering description.
So it is specified now that part has been accepted. It is specified that storage is 2's complement for integers.
Right.
Okay.
Yeah.
And then now this gives the core libraries something to do to give us more tools around that, basically.
Exactly, yeah. Yeah, and that work was ongoing before I presented my paper, right? So it's not like I made it happen. I think I just kind of precipitated things a bit and told people like, okay, well, if the language is not going to do it, the library really should be doing it. And so numerics is looking at that pretty intensely. I think they met in San Diego at the same time as my group was meeting, so I wasn't able to attend, but I think that's one of the things they've been working on.
Do you have any idea what that'll ultimately look like? Will we have new strongly typed signed integer wrapper type things, or?
Yeah, I would hope, and it's probably something that you can customize through templates or whatever, what type of behavior you want, whether you want wrapping or trapping or something like that.
Right.
But I mean, I've worked on a handful of code bases that have this type of templated integer and floating point, safe helper. So Clang has some with its APInt class and AP float class, so the arbitrary precision ones. Those are used to implement things like const expert and stuff like that. And so those allocate when you overflow and things like that by just, being effectively a big implementation. But then Chrome and WebKit both have implementations of effectively the same thing, which allow you to detect whether overflow occurs. And so any untrusted input in browsers just goes through that type of class, because you just do the arithmetic. You don't trust yourself to do it right. You don't trust the user to not be malicious. And so it's kind of your security boundary. Anything that comes from potentially malicious sources, you feed it through that integer class, and then you check whether something bad happened or not. And Firefox is the same thing. I think it's called SafeInt that they use. So there's a handful, and I think I mentioned them in my talk as well. But it's a very common thing. It's just a question of what do we want the standard one to look like.
Yeah, that's assuming the performance characteristics of it are good, or as you say, if there's a templated set of things that we can choose. In the emulator I was working on recently, I had to deal with integer overflow and then set the emulated CPU flags appropriately. And the best way I could come up with to do that was to do 32-bit math in a 64-bit value and then check to see if any of the higher order bits were set, basically. And
so compilers have built-ins as well for that. If you look at built-in add and things like that, so they can do that work for you as well.
Okay.
That's another way that people do it. Or you cast to unsigned, you do the arithmetic, and then you cast back to signs, right? So a lot of the instructions, like add and multiply, are exactly the same. So that's another approach to doing it.
Right.
So going back over some of the other features that made it through Core and Evolution, there were a lot of changes made to constexpr, is that right?
Yeah. So there's a big push to make everything constexpr, and so Louisiane, who works at Apple and maintains libc++ for us, has been instrumental in that, and he's got a lot of support from people like David van der Voort, who's at EWGI, and they're just attacking every single constexpr thing one at a time to try to make it possible to have things like constexpr string and constexpr vector and other things like that. And so some of what they did was just allow unions to be constexpr, so that an implementation of string that uses the small string optimization can be constexpr, right? Mm-hmm. So and part of the concern they have is, well, they can't break their API, their ABI through C++20, and so you want whatever is implemented right now to just be constexprable, right? So union was one of the requirements here, and so what that does basically is the compiler has to track what the active member of a union is through constexpr evaluation, which initially was thought to be pretty hard, but people kind of experimented a bit, and it turns out it's not that hard, especially for EDG, because EDG emulates a lot of other compilers, and so the worry was that for them it'd be impossible, but they tried it out and it's not, so they were really happy to go with that. But there's other stuff like, constexpr try is something. So you can't throw in a constexpr context, but you can have try and catch, and if you encounter them, it's still a valid constexpr. Then constexpr dynamic cast, constexpr type ID, constexpr pointer traits, and there's a handful of other stuff. Eventually we'll get, constexpr allocations in the standard as well. So that'll allow you to eventually have just, vector with pushback and other stuff, all be constexpr.
Do you expect... Yeah. I'm sorry, go ahead.
Yeah, go for it.
Do you expect that the constexpr allocation will make it into 20, or do you expect that's something we'll see later?
I'm not sure. I think there's someone in my team who started working on implementing some of those aspects for LLVM.
Okay.
And especially for allocation, I think we might need some implementation experience to make sure that what we're doing makes sense. Because
right.
You want the allocation to whatever you've created as a vector to then be usable at runtime, and so I'm not sure it'll make it to 20, because papers that were presented in San Diego to the language group can potentially make it to 20, and I think that one was discussed, but it's a bit tight. So I guess we'll see. We still have hope that it might, but it's really not clear, and I wouldn't put money on it.
Right.
Okay. Another feature I wanted to talk about was the revised memory model. What is changing exactly? Right.
So SG1 is the group that does concurrency and parallelism, chaired by Olivier Giroux, who you've had on semi-recently. Mm-hmm. And part of what they do is they own like atomics and executors and a bunch of other stuff like that, like futures and async, and part of the memory model for coroutines and stuff. And what they've done over time is they've tried to have a formal proof that the memory model holds on existing architectures. So there's a guy who did a PhD under Peter Sewell called Mark Batty, called Mathematizing C++ Atomics or something like that. I don't quite remember. But the idea was that when you write atomics and you don't have a data race, then on every architecture that C++ targets, you can prove that your program behaves as if it were sequentially consistent, right? So the model is called sequentially consistent for data race-free programs. That was published in the early 90s, I think, by Sarita Adve. And the idea is to use theorem proving to prove that that's the case, right? So it's pretty rare that you can prove anything about programs. And it's kind of interesting that they've done that for atomics, and especially since atomics are very unintuitive to use in a lot of cases. It's nice that, if you stick to these rules and, release acquire and sequential consistent things, then your program will behave in this bounded set of ways on all the architectures that you target. Now, since theorem provers are also themselves programs, it turns out that there was a flaw in some of the theorems. And so they found that flaw, and they've been working at kind of fixing things, right? So the idea was, well, some really weak architectures like Power and NVIDIA's GPUs, weak in the sense of the memory model, don't actually obey what C++ said should be obeyed. And so we can either say that they're non-conformant, or we can fix the memory model to make them conformant. And what you end up doing there is looking at the programs that are non-conformant, saying, would anyone actually write this code? Does anyone rely on this? And it turned out that nobody would. It's programs with like 4 threads doing weird things with like different accesses to the same variables using acquire, release, and relax and sequential consistent. Like, nobody does this. And so they found a way to fix the memory model to still be compliant on those architectures without degrading performance. So they're really minor fixes. It's really kind of a niche topic, but it's really important for hardware people to know that people writing C++ code will have expected outputs when that code is executed on their architectures. And so for them, it was really important. And they spent a bunch of time trying to fix this, and finally came up with something that everyone thought was palatable. So I think it's pretty cool if you're into that type of topic. For most people, you can just keep using atomics and it'll still do the same thing, right?
Right. I thought we had covered basically everything. Oh, nested inline namespaces are left, huh?
Yeah, so that's another thing that we discussed, and I think we moved to C++20, and I'm not a fan of that one, I have to say.
Okay.
So the idea is you can, when you have inline namespaces, you want to be able to nest them and kind of say like, oh, I'm in this namespace right now, but it's inline. And so you can say right now in C++ 17, I think, like, namespace foo : bar : baz, and then open a curly, but you can't do that if it's inline, right?
Okay.
And, what this does is it allows you to put inline in there to say, oh, actually it's inline. First, the syntax I think looks kind of ugly, but it's not that bad, right? But it's not really fixing what inline namespaces wanted to fix, is my opinion. And the goal of inline namespaces was to be wordy, right? So I kind of don't mind having type more stuff when you're using an inline namespace, right? Like, I agree it's convenient to type less, but in this case, that was kind of the point. So it's not a big deal. At the end of the day, I just won't use that feature and whatever. But some people really wanted it, and it got enough consensus in the language working group that it moved forward. So that's kind of how the standard works, right? Some people think some stuff is important, some people think it's not as important, and you kind of want to allow people to get the features that they want outside of the language. And if you don't like it, you don't have to use it in this case.
Right. Was there anything that was a highlight for you, JF, that we haven't gone over yet?
So one thing that I was really enthused about is I wrote a paper about deprecating volatile, and I've been joking about this for a while, and finally pulled the trigger and wrote that paper. And first I wrote the paper with the title Deprecating Volatile, just to get people to click on it, because and they're like, "Whoa, you what now?"
Clickbait with the standards committee, in other words.
Exactly. And I think the subtext should really be deprecating most of volatile, or deprecating the bad parts of volatile. And so I think I made a pretty strong case first for why volatile is the way it is, right, in the paper, and then for why I think we should deprecate parts of it in C++ and in C. So I'm going to have to try to talk to the C committee about some of that volatile stuff. Now, I think everyone agrees if you design a language from scratch, you wouldn't design it with volatile as it is in C++, right? You'd have something like a volatile load and volatile store, and volatile, non-tear load and non-tear store, and that would be about it.
Okay.
It would participate in the memory model. So languages like Rust and other languages do stuff like that already. But So volatile has useful semantics. I try to go through them in the paper. I want to preserve those, so the valid uses of volatile, but I want to remove the ones that are super error prone or that are really non-intuitive, right? So for example, if you have a volatile variable like B and C and you do A equals B equals C, how many volatile loads and stores did you perform doing that? Well, it depends if you're on C, C++, and which version of the language you're using. So stuff like that is just really unintuitive. And so my paper goes through the stuff I think is important that we want to preserve, even though it might be distasteful and we do it some other way. Like I don't want to break those uses, right? What low-level code like kernels do, we want to preserve those. And at the same time, what's unintuitive, what's usually broken when you write it, what should you not do? And I had a bit of fun writing the paper too, so I kind of quoted one of my favorite books from Patrick Rothfuss in the book, in the paper, kind of using some of his quotes. I thought that was pretty fun, and he seemed to enjoy it on Twitter too. That was pretty great. So overall, the paper got really good reception from the committee, and I'm going to send an update for the next meeting, proposing actual wording changes, not just, hey, how about we do these things? So I got really strong support from the committee for that. So that was my personal highlight because I was pretty excited about it. It's in my vein of trying to deprecate things out of C++ that we shouldn't have anyways, right? So without breaking people's code, I'd like to simplify the language and bring it to look like a more mature language, like a more well thought out language.
Yeah, it looks like a very mature language at the moment.
Right. It has all these words. I'd like it to be mature and pretty. And Bjarne was really clear. If you've read Design Evolution of C++, from early on, he put volatile in C++, but he wasn't really happy about what was there. It's just people felt like they really needed it, and they did. And so he wanted to have a solution for them without without breaking compatibility with C. And that's really why it's there. And then it kind of feature crept into looking like what const looks like, right? So into qualifiers and other stuff, and you can qualify member functions with it, and arguments and return values. Like, what does it mean to have a volatile argument? Well, for function passing purpose, it doesn't mean anything. The calling convention is exactly the same. It doesn't show up in the ABI. It just means something local to the function itself. And same thing for a volatile return. It doesn't mean anything. You can, in fact, have the for declaration not have the volatile and have the actual function definition have it, and it's totally valid C++. And so there's a lot of really weird stuff that volatile has that's kind of accreted through what was perceived as consistency with const. And I think that's kind of a misfeature that I'd like to get rid of.
And I think if we could take just a second to back up and make sure maybe I could try to summarize what you said. You want to remove most of volatile, but leave some ability to do a volatile load and a volatile store. And for our listeners who are not aware, if you can correct me if I'm wrong, please, the only legitimate use of volatile is when you're talking directly to hardware. So this volatile load and volatile store would be, I need something at this address right here, please.
Well, yeah, so there are actually a few valid uses of volatile, and I go through them in the paper. So load and store are really the main thing, and that it's not normative, but what the language says in notes and in the design intent papers that accompany the language is that if you wrote volatile in the code, then the abstract machine should do a load or a store, right? Like that's what should happen.
Right.
And it's really hand-wavy how it's specified, but we kind of all understand what's going on, right? The idea is like you might have a register that has special meaning or a memory location that does special things when you touch it, and you really want it to happen.
Right.
So that's the main usage that I've seen for volatile. But there's uses for something like shared memory, where eliding a load or a store through shared memory could be a security issue. And so I have a few examples of that of actual exploits in the paper where a hypervisor or a browser used shared memory but failed to use volatile, and the compiler just removed the load or the store. And so that means that you have a time of use bug in your code. So you can cause a race to happen, and if you're on the other side of the shared memory and you're a malicious program, and you can cause a higher privilege process to do something it didn't want because it loads the size twice or something like that. Then it's valid to use volatile for set jump and long jump to preserve values across the set jump. So when you long jump back, the value is still there. That's important because set jump can return twice, which no other function can. And so the compiler has to know that it has to preserve that value across that twice returning function. And then it's also valid to use for signal handlers. So that's the other use case for that.
Oh, okay.
Signal handlers kind of behave the same as set jump, long jump in that case. It's like, well, the value should be there. Now, the thing to keep in mind is volatile can tear, right? And volatile doesn't participate in the memory model. It's not sequentially consistent or anything unless you use volatile atomic. And so it's really hard to use properly if you're trying to do certain things, right? And there was a feeling initially pre-C++11 that volatile could be used to make threads happen. And in a way it was, right? Like, so Microsoft's implementation of C++ on x86 to this day guarantees sequential consistency for volatiles load and stores. It might still tear on their implementation, but it'll be sequentially consistent. If it doesn't, and if it tears, then it tears in a predictable order. And so there's kind of a wide breadth of implementations of volatile. And it's really, especially when you're trying to deal with hardware, it's really up to the vendor of your compiler to tell you what that specific thing means on that specific hardware.
Right.
So yeah, it's a bit tricky, and I'd like to make that a bit less tricky, right? Keep the good uses and just get rid of the bad ones.
Okay.
Right. Okay, well, it's been great having you on the show again, JF. Where can people find you online?
Online, well, so I have my usual Twitter account where I just tweet jokes about C++. I don't really tweet anything serious. People take me seriously, but I don't, like, please don't. Otherwise, I don't know, I participate in LVM quite a bit, and if they want to meet in person, I'll be at the LVM meetup and other things like that. So CppCon is another place where I hang out. I try to not go to too many conferences because it's kind of hard with a kid to do that. Mm-hmm. But I'll usually show up at CppCon and the standard meetings.
Yeah, but between the standards meetings, the LVM meetings, there's not a lot of time left for conferences, I would imagine, besides...
Right, well, the LVM meetings are more kind of LVM socials in the Bay Area, and so they're kind of once a month. I can usually go there, bring my kid.
Okay.
And it's not just LVM people, it's more like people interested in LVM, but most of the people who contribute to LVM in the Bay Area usually show up, like
right.
Semi-frequently. So it's kind of neat to meet people you effectively work with in the open source community and be able to move things forward more easily than through email or IRC or something like that. And because there's often our colleagues in other companies also work on the standards committee, we also end up kind of talking about standards committee related stuff as well.
Right.
So it's kind of an interesting little group of people.
Cool.
Okay. Thanks again, JF.
Yeah, thanks for having me.
Yeah, thanks for coming.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. At cppcast.com. Theme music for this episode was provided by podcastthemes.com.